2D lists. In this video, we will extend the list data structure to create a two-dimensional list. In the previous unit, we defined a list as a heterogeneous, mutable data type that stores an ordered sequence of data. As you already know, that data could be an integer, it could be a string, it could be a floating point value, it could be any type. And the values within a single list do not have to be the same type because, once again, lists are heterogeneous. What was not revealed in the last unit, however, was that one of the values within the list could also be a list itself. Consider the following program. In this first line of code, we declare a list that contains 4 floating point values. Rather than display this list on the output console, I'm going to use a visual to illustrate what this list looks like. So, at index 0, we have the value 1.0. At index 1, we have 2.1. At index 2, we have 3.3. And at index 3, we have 4.2. Then, in the next line of code, I'm going to call the append method to add 5.5 to the list. As was learned in the previous unit, anytime we call the append method, the value that's inserted between the parentheses will simply get added to the end of the list. Okay. Now, suppose I choose to append an entire list itself. Okay. In this case, we have a list of floating point values. Well, at index 5, rather than having a single value at that location, we're going to have a whole list of values at that location. Now, suppose in the next line, I attempt to print out the value located at index 0. Well, in this case, the value index 0 is simply 1.0, so that is what will get printed out to the output console. Now, suppose I attempt to print the value at index 2. Well, in that case, the value at index 2 is 3.3, so that's what will get printed out. However, suppose I attempt to print the value at index 4. Well, in that case, the value at index 4 is 5.5, so that's the value that will get printed out in that case. That all being said, suppose instead I attempt to print the value at index 5. Well, as you know, the value at index 5 is not just a single value. It's a whole list of values. So in that case, an entire list of values would get printed out to the screen. Now, suppose I don't want to print out the entire list. Suppose I just want to print out a single value within that list. In that case, it should be noted that each of the individual values within that list each have an index as well. So if I only want to print out a single value within that list, for example, 4.4, then the first thing I'll need to do is type the index where the list is located, which in this example is 5. Now that that's typed out, I will next need to type the index of the value I want printed out, which in this case is 2. That is where 4.4 is located within the list. So, in general, anytime you have a list within a list, aka an inner list, and you want to access a specific value within that inner list, first you'll need the index of the inner list, the index where that inner list is located. Then you will need the index within that inner list, where that specific value is located. Now, suppose I want to access more than just one value within that inner list. Suppose I want to access the last 2 values of that inner list. No problem. We can use slicing on an inner list the same way we would use it on a regular list or a string. Here in this example, we're saying give me all the values of that inner list starting at index 2 all the way to the end, thus giving me the final 2 values of this inner list. It should also be noted that all the list methods that we learned about in the previous unit can also be used on an inner list. For example, suppose I want to append 20.5 to the inner list that we have here. Once again, I'll need to use index 5 to access that list. Then after that, type .append to call the append method, followed by the value I want appended to the list, which in this case is 20.5. Now, be aware, typing mylist bracket 5 .append is not the same thing as simply typing mylist.append. When I simply type mylist.append, that means I'm asking to add a value to the main list. So in this case, 20.5 would be added to index 6 of the main list. It would not get added to the inner list. Now consider the following program. We start off by declaring an empty list named mylist. I then append a list of 5 zeros to it. Let's not forget that each value within this list will also have an index of its own. Now, suppose I append another list of 5 zeros to it. Then I append a third list of 5 zeros to it, and another list of 5 zeros to it. What we have here is an example of a two-dimensional list, also known as a matrix. A matrix is a list where every single value stored inside of it is also a list, and each one of those lists all have the same length. Now, as a programmer, why would we want to work with a two-dimensional list? The reason is because many real-world entities we like to represent using a two-dimensional structure. For example, a chessboard or a checkerboard, or even a picture. Okay? These are just a few examples of real-world entities that we, as programmers, use two-dimensional data structures to represent. Now, going back to our list. Indexing on a matrix works the same exact way indexing would work on any list. If I, for example, want to print out the value at index 1, then that would then print out the entire list that's located at index 1. Similarly, if I were to use slicing, if I were to say, hey, print out all values starting at index 1 all the way to the end, then that would then print out each list starting at index 1 all the way to the end. If I want to print out a specific value inside the matrix, then I'm going to need a pair of indexes. First, I'm going to need the index of the list, then I'm going to need the index of the value within that list. For example, if I were to type index 2 followed by index 3, that would mean go to the list located at index 2 of the matrix and print out the value at index 3 of that list. Now, suppose instead of printing out that value, I want to modify that value. I want to change that value to a new value. Once again, I'm going to use a pair of indices to specify the exact location that I want to modify, followed by the equal sign and the value that I want stored there, thus inserting 25 at that location. The final observation that we'll make about this matrix is that in creating it, we executed the same exact statement 4 times. What do we know about statements that get executed more than once? We know that we can simplify our code by simply using a for loop. Here, since we executed the same line 4 times, we could declare a for loop that'll repeat 4 times, then inside that for loop, have it append an empty list of 5 zeros, giving us 4 lists of 5 zeros. That being said, since each value in the list is the same, this code could be simplified even further. Rather than typing out the full list containing all 5 zeros, we could write just a list containing a single zero and multiplying it times 5. When you multiply a list times an integer, the contents of that list will get duplicated that number of times. So in this case, where we're multiplying a list that contains a single zero times 5, the 0 will get duplicated 5 times, producing a list that contains 5 zeros. Then of course, that'll get repeated 4 times since it's within a for loop that executes 4 iterations. With that said, suppose I don't want the initial values of my list to all be the same. Suppose I want my list to store the first 5 positive integers, for example. Well, one way to do that, of course, would be to simply type out the list containing the 5 values I want stored in there. Then when I execute the code, we'll have 4 lists with each of them containing the first 5 positive integers. Now, suppose, however, I wanted the list to contain the first 100 integers or the first 1,000 positive integers. Obviously, typing all those numbers out would be very tedious and would make the code much more difficult for other programmers and myself to read. Fortunately, a more efficient approach exists by way of the nested for loop. So, instead of appending the entire list in just one line, we can start by appending just an empty list. Then, with a nested for loop, we can then append the values 1 through 5 to that inner list. What makes this approach so special is that now, if we decide later that we want to add the first 50 positive integers or the first 1,000 positive integers, instead of having to type all those numbers out one by one, all we have to do is change the parameter passed to the range method.